Okay, so we're back working some of the sample problems from your homework. This is over the inequality section, so section 1.7. So first of all, we start with just the idea of looking at it as an inequality and what does that look like in interval notation. Now what helps me sometimes if you draw the picture of what they're saying, I know that the less than symbol, less than means to the left, so I locate where I want to say -4 is, and there's really no right way to do that. You can show where 0 is and other numbers, but it's not necessary. Just say, hey, there's -4, and it's all the numbers less than -4. Now, there was no line under that. That was me just pointing this out, but there was no line under that originally. So just strictly less than means don't include the endpoint, so we use a parenthesis, and then less than goes to the left. Now, what does that answer look like in interval notation? You can say to the left it goes to -infinity, and how far does it go to the right? To -4 with a parenthesis. Parentheses again means that we don't actually include the endpoint, and you can't ever include infinity. You can't get to infinity, right? So you can't include that endpoint, and if it's going to the left, it's a -infinity. All right, so let's find that answer. Correct answer below, and I'm not actually seeing it. Oh, there it is. Oh, sorry for my slowness there. Oh, there's too many choices there, right? So too many choices, and just there was the very first one, so maybe you'll have that problem too, or maybe I'm just slow there. Okay, there's number 1. Number 2, another question like that. This means x is between the endpoints -8 and +4. On a number line, like I like to see it visually, that means from -8 without a line under it, and then less than or equal to 4 will have a bracket since it has a line under it. So it's all the numbers. X is the numbers, if you read it from x's perspective, greater than -8, but then also less than or equal to 4. And that's how that would look. So -8 with a parenthesis to +4 with a bracket. And then let's see if I can find this one a little faster. Okay, there it is. It's C. Answer C. Okay, number 3. Greater than or equal to -9. So we're going to include the -9 because there's a line under it. And then greater than goes to the right all the way to +infinity. So -9, infinity. So find that solution, and that looks like E. Oh, no, -9, sorry. Oh, there's too many choices on these. I apologize for that. It kind of messes with my eyeballs. -9 to +infinity, C. Okay, now we're going to solve some of our own inequalities. This one working out. So a linear inequality, solve almost like a linear equation, as if this were an equal sign. You can throw the 5 across the line and divide by the -6, just like we do with equations. But the only difference, the thing to be aware of, is when you're solving linear inequalities, is if you divide by a negative to solve, divide by -6, that will flip this inequality and make that x is greater than or equal to the answer here, which is -2. So, and it says the solution set, write it in interval notation. So I'm going to draw the picture like I do. Greater than or equal to -2 has a bracket, -2 to +infinity. All right, so what goes in our solution? -2 bracket, +infinity parenthesis, like so. Okay, another linear inequality. It has 3 parts, we'll notice here. So we're working from x being in the middle, solving for the x variable. We will -5 to get x alone, -5, and it has 3 parts to -5 from. So you're keeping the balance on all 3 parts. So when we -5, it does simplify it, so the middle 5 drops out. You've got 2x in the middle. 13 minus 5 is 8, and -5 minus 5 is -10. Then we will divide by the 2, and we will accomplish getting x alone and in the middle to see what x is between. So x is between -5 and +4. We could read that also from x's perspective. X is greater than the -5. You'd have to read it backwards to read it from x's point of view, and x is less than 4. So on a number line, x is all the numbers greater than -5, but also less than 4. So it makes a closed interval between -5 and 4. And again, all parentheses, there's no lines to include the endpoints here. Number 5. Okay, number 6. Another 3-part inequality. So I want to get y, or the variable, alone and in the middle. So I'm -18 from all 3 parts, so that cancels, leaving 3y in the middle. 18 and -18 is 0. 15 and -18 is -3. Then you want to divide by what's with your variable. Divide by the 3. It's the 3 to cancel, and then it leaves y alone in the middle. 0 divided by 3 is 0, and -3 divided by 3 is -1. So y, or the solution, is between -1 and 0. And notice there's lines under both of those endpoints, so I do need brackets, and then the interval between those. So -1 to 0 with brackets. Okay, so those are your linear inequalities. You have 3 types of inequalities in section 1.7. We have linear, so that was your practice problems with those. And then you move to quadratics. Notice on number 7 we turn to a quadratic. Then the last topic of 1.7 is the rational or the fraction inequalities. And each one has their own little special step or rule. So the rule with the linears that we just completed is if you divide or multiply by a negative, you have to flip the inequality. And we did that on maybe 1 or 2 of those. Now when we get to the quadratics, the rule is you solve the quadratic just like you would any quadratic equation. Get it in standard form if it's not already, and then factor it or use the formula, one of your quadratic methods, to solve that. I'm going to say x minus 5, x plus 3 works, FOILs correctly, giving us 2 solutions to the quadratic. So once you get the solution to the quadratics, those are only endpoints for our number line. It cuts the number line into 3 sections. So it cuts the number line at the endpoint -3 and at 5. Those are the 2 solutions, if you plug those in, that would make it equal 0. But we're looking for greater than 0. So we're going to have intervals, either this interval, or this interval, or some combination of those. So we plug in some values or test points to see which parts is it. Is it these outer 2 parts, or is it the inner part? And the way we know is by a test point, like maybe you try 0, it's between -3 and 5 in this interval. If you, when you take your test point, it should be the same result as whether you take 1, 2, 3, any number within this interval should give you the same result, either a true result or a false result. But all the solutions should go together. So just one test point, and we carefully plug it back in for our x's and see how it goes here. So 0 squared minus 2 times 0, all of that's just 0, and then minus 15 makes -15 on the left side. And then we say, is this a true statement? Is that greater than 0? And we know that it is not. So we can say that interval must not be where the solutions are. That is not part of our solution set. So then we test, excuse me, in the other sections, like maybe take -4 or -5 out of this section, and maybe test in this section. I'm going to show you that just to be thorough. I'm going to take 6. Now I'm feeling like this section works because it's usually either the inside or the 2 outsides. So I feel like this is going to be a yes. But let's confirm it. 6 for x, plugged in for all the x's, and then determining if that's true or not. So that's 36. Oh, I forgot to plug in 6, didn't I? Minus 12, minus 15. Let's see, 36 minus 12 is 24, and then 24 minus 15. Would that still be greater than 0? Yes, that's 9, right? So 9 is greater than 0. That's true. So these values when plugged in must work or be part of the solution. So I'm going to say shade that region. Now also this region, we can take a test point and prove it, but that region is going to work as well. There is no line under my inequality, so I'm using parentheses around those endpoints. And so my solution is two sections, this section plus this section. So the way we write that is, this is negative infinity, comma, up to -3, parentheses, union, sort of like our plus sign in math, and then 5 to positive infinity. And that's how we would say the solution set is on A. All right, so we're doing it again. Now what I recommend you do is pause the video to be more interactive with me and practice this and see if you can do it on your own before watching the demonstration. But we're going to do the same procedure here. We're going to pretend it's an equal quadratic equation to get our boundary lines where it cuts through the number line, our endpoints. And this, oh, this does not factor. No, there's no way to get the middle term of 3. If I put 2 times 2 to get 4, that gives me a middle term of 4x. If I put 4 times 1, it gives me a middle term of 5x. So actually, that one does not factor. So what do you do when you can't factor? You use the quadratic formula. So, quadratic formula for back up here would be A is 1, B is 3, C is 4. And let's plug that in our formula. Negative B plus or minus B squared minus 4AC all over 2 times A. Oh, I can see what's up with this one right now is we're going to get an imaginary number. So it doesn't even show up on our number line for our real solutions. We can't actually work this one, but notice I have 9 minus 16. Now if the answers would have been positive and not imaginary, positive under the radical, I would have kept going and I can get an estimate for values even when I use my quadratic formula. But look at this, 9 minus 16 is -7. So we're in the imaginaries. And I don't know if I've said this in class yet or talked to you about this, but when we are graphing, we are only graphing in the real numbers with the x-axis, the horizontal x-axis, whenever we're graphing these. And then in the next chapter, we'll add the y-axis. But we only graph in the reals. So if you run into an imaginary number, it will not show up on your graph. So actually, because of the negative there, we can say the solution is the empty set. Okay, let's do that one more time. Okay, let's see. This time, I wonder if this one factors. I don't think it does. So we're going to be, you can try that and think about it. It's x times x. 19 times 1 certainly doesn't give me an answer of 6x in the middle. I think the same thing's going to happen on this one. But let's just check it out. Let's plug it in the formula. A is 1, B is 6, C is 19, negative B plus and minus B squared, which would be 36, minus 4 times A times C, all over 2 times A. So 36 minus 4 times 19. 4 times 19, let's see, what is that? 4 times 19 is 76. So we have a 36 minus 76. We're in the negatives again. 36 minus 76 is certainly a negative number under the radical. So we're in the imaginary numbers again. And like I said on the last example, the imaginaries do not show up on our graph. So because it's an imaginary, we will say the solution set is the empty set. Empty set, no solution for us in the real graphic, real number system. All right, I'll come back on the next video and we'll talk about these fraction examples.